Anusha. I'm a rising junior at Monte Vista High School, and this is my self-designed project, the ASL robotic hand. Now, as Sebastian mentioned, I designed this on my own, and I designed this to be like a teaching tool. So you hold up a word or a letter to it, and it shows you how to spell it in sign language. So I will show you my demo now. I am going to be running my code, and here we go. Yes, so a video feed is going to be started up, and there is a camera right here. You can see yourselves. Takes a second. There we go. And I'm going to hold this up to it. It says blue, and it has captured a picture because I have pressed a key on my keyboard. And the video feed continues, but if you look at the terminal, it tells you the information that the camera was started, a image was captured, and it was saved, and once the image is saved to a variable, it is sent to the OCR model. OCR stands for optical character recognition. This is what executes the text recognition. And for this, I use the software Keras OCR. Oh look, you can see it signing now. So it tells you what word it has recognized, blue, and it tells you what letter it's signing at the same time. So right now, it has just signed B-L-U-E, blue. Yeah, so to control the hand, it's basically made up of 5 servos, one for each finger, and I have to set each finger to the correct angle measure to make the finger bend a certain amount, and I have to program all 5 fingers to form one letter, and I had to write multiple functions that are called when I parse through the string that is returned through the OCR, and based on which character it has detected, it will call the necessary function to set the hand into the right position. So throughout this process, I faced many challenges, especially because there was no guidebook for me to follow. The biggest issue I had was with my video feed. Originally, I wasn't using the PyCamera 2 library, which is the most compatible library with the Raspberry Pi. And since I wasn't using that, the video feed I had was at 0.3 frames per second. For context, right now it is at 30 frames per second, 100 times faster. Earlier, it looked like a slideshow and it was so tedious to watch and to get it to function. But what I realized was initially I had downloaded so many libraries to my Raspberry Pi, and I had installed them to the base instead of creating a virtual environment when downloading them. As a result, the configuration settings were messed up, and it was hard for all of the libraries to be functioning at the same time. So as a result, I had to restart my project, start with a new Pi, a new camera, and since I learned from my previous mistakes, I only downloaded the necessary libraries to my virtual environment, which you can see that I've activated up top. And once I did that, it was pretty nice to set up, and I came up with this finished product. And then I created a case for it using CAD or computer-aided design so that it all fits together nice and snug. So the reason I chose to do this project was because there are so many developments I can make to it in the future. This is an important tool, and at the end of the day, technology is used to help make people's lives better. And I can make hardware improvements and make the hand bigger or make a custom hand so that it can sign a variety of words and symbols. Or I can find better software that can perform the text recognition process much faster or recognize objects in addition to text. And that was one of the most exciting parts of this project. At my time here during BoostM, I have learned so much. I have learned how to use a Raspberry Pi, which is an incredible piece of technology because it's a little computer all on its own. I've learned how to CAD and create 3D printed pieces, and I've learned how to implement machine learning and AI in my projects. And under the guidance of my wonderful instructors, I have been able to become confident in using these skills, and I'm looking forward to using them in future projects. Thank you.